We now deal with a new topic called manipulating formulas or changing subject of the formula. So you come across many different types of formulas, equations in maths and engineering science. You must be able to manipulate the formula. Okay, so here we are dealing with the exercise from the textbook, exercise 4.8, page 80. Okay, we start with 1a. The instruction here, make the symbol that appears in brackets after each equation the subject of the equation. So here we got 1 over s plus 1 over t is equal to 1 over w, and you got t in brackets after the equation. In other words, make t the subject of the formula. Okay, so this one I already have worked out. So notice that we have fractions here. Okay, you will come across many different types of equations. We could have fractions. Here, clearly, we are adding fractions. When you are adding or subtracting fractions, remember to find the lowest common denominator. Okay, so here the question is make t the subject of the formula. So where is t? There's t here. T is part of the fraction 1 over t. Okay, so 1 over t is what you need to try and get alone on one side first. So isolate 1 over t first. That means get it alone. So what did I do here? I kept 1 over t on the left hand side, and then I took 1 over s to the right hand side. So when you take it to the right, the sign changes. It was a plus 1 over s, it becomes minus 1 over s. Now, okay, what we have here is a fraction subtract another fraction. Fraction minus a fraction. So what do? We find the lowest common denominator. So your denominator here is w, and here you have s. If you multiply the two denominators, it will be ws. Okay, so here I'm just using a shortcut. You just multiply the denominators ws. So you know 1 needs to be multiplied by s, and this one needs to be multiplied by w. Okay, so 1 times s, that will be s, 1 times w, that's w. Now, once you have your LCD, okay, that means you have a single fraction on the right hand side now. Okay, a single fraction because it has just one denominator here. So once you have a single fraction on both sides, okay, once you have a single fraction on both sides, so I got, here is the rule. So if I got x over y is equal to a over b, then if I swap the left hand side here, if I swap numerator and denominator on the left hand side, so that means if I change here, this will become y over x, and whatever I do on the left hand side, I must do on the right hand side. So then y over x will equal to, if I swap the left, y over x will equal to b over a. Okay, now that's exactly what I did here. So here my left hand side is 1 over t, my right hand side is 1s minus 1w over ws. So if I swap the numerator and denominator on the left, if I write it as t over 1, that means I have to swap numerator and denominator on the right hand side. And then finally we know that anything divided by 1 is equal to itself. Okay, so t divided by 1 is t, and now t is the subject of the formula. Alright, so now let's look at this example and then apply our knowledge to work out this one. It's a similar type of example here. Here we need to make y the subject of the formula. So y is part of the fraction 1 over 2y. So we will need to isolate 1 over 2y first. So I got 1 over 2y on the left hand side. Here this will be 1 over 3z minus 1 over x. So now what do I need to do? I need to find the LCD on the right hand side. So my LCD here, all I will do is just multiply these two denominators. That's going to be 3z times x. So this one needs to be multiplied by this denominator, and this numerator 1 will have to be multiplied by that denominator there. So therefore we got 1 times x, and this will be 1 times 3z. Okay, on the left hand side you still have 1 divided by 2y. So now I have a single fraction on the right, a over b, a single fraction on the left, x over y, which is 1 over 2y. All I will do is swap numerator and denominator. 2y over 1 will equal to 3zx divided by x minus 3z, and 2y divided by 1 is equal to 2y is equal to 3zx minus x divided by x minus 3z divided by x minus 3z. Now all we have to do now is get rid of 2 because I need to make y the subject of the formula. I have 2y, so all I will do is multiply by 1 over 2 on both sides. So let me just write that down. I got 2y there, I got my 3zx all over x minus 3z. So I do not want the 2 there, so in order to cancel 2, I multiply by 1 over 2. So now 2 and 2 cancel, I end up with just y on the left hand side. Now remember, in an equation, whatever I do on the left hand side, I must do on the right hand side, so I'll multiply by 1 over 2. So now 2 and 2 will cancel, you end up with y over 1, which is just y. Here you got 3zx times 1. When you're multiplying a fraction times a fraction, it's numerator times numerator. 3zx times 1 will be 3zx, and then denominator times denominator, so 2 times x will be 2x minus 2 times 3z, that will be 6z. Okay, or you could have left it as 1 over 2 in brackets there, because y is the subject of the formula. Alright, so fractions, you can see, involve LCD. Now, a similar example again. We got 1 over RT, that means 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. In engineering science or physics or electronics, this is the section on electricity. This is the formula for resistance in parallel. So what happens if you're given the total resistance, you know the resistance of R2 and R3, and then you just want to find the value of R1. How do you do that? You need to manipulate this equation. So here the question is, make R1 the subject of the formula. So where is R1? R1 is part of the fraction 1 over R1, just like y was part of the fraction 1 over 2y, t was part of the fraction 1 over t. So you isolate the fraction first. Okay, so here I got 1 over R total minus 1 over R2 minus 1 over R3 is equal to 1 over R1. Okay, so we isolate the fraction first. Now, just like what we did there and there, we need to find the LCD. Okay, so let's look at the denominators. We got RT, R2, R3. These are completely different factors there, or different expressions, RT, R2, and R3. So when you multiply them, that will be your LCD, or the lowest common multiple of the denominators. So if I multiply them, that's going to be RT times R2 times R3. So this one here has to be multiplied. Now you see, this is RT. You got RT there. What's missing is R2 times R3. So therefore, that's going to be 1 times R2 times R3. Then we have minus this one. You look at this denominator, which is R2, and you already have R2 here, so what's missing will be RT times R3. So this one is going to be RT times R3. Then you have your last numerator there, which is 1 multiplied by, you have R3, so what's missing here will be RT times R2. So that will be RT times R2. And all this is equal to 1 over R1. Now we have a single fraction on the left hand side, a single fraction on the right. So we always go back to this step. If x over y is equal to a over b, if you swap the left, you swap the right. So if I swap the left hand side, this is going to become RT times R2 times R3 divided by R2, R3 minus RT, R3 minus RT times R2 is equal to R1 over 1. And we're almost done now. So therefore R1 divided by 1 is just R1 is equal to, and then what do we have? We have RT times R2 times R3 divided by R2 R3 minus RT R3 minus RT times R2. So that's how we deal with adding and subtracting fractions. You can see this is an example from engineering science, resistance in parallel.